Alright, so now I'm going to talk about free body diagrams and how to mess around with them in order to get what you want from them. So, in the previous video, we were talking about how to decompose forces into, say, one component and another component, using the tail to tip method, which is the tail of one goes to the tip and then the tail of the next goes to the tip, and that should give you your original thing. So, how is this going to help you? You have this problem here. You have a bar over here. We're not going to consider it having any mass. And then masses, let's call it mass 2, mass 3, and this one mass 1. Mass 1 has 5 kilograms. Mass 2 has 2 kilograms. Mass 3 has 3 kilograms. So you're going to want to make one free body diagram for each. So let's start with mass 1. Always label it so you don't get confused. So now, you're going to have mg. You hope there's gravity. Now the next thing, you're going to have some normal force. Now, we also have this funky force with some theta. Now, usually you don't want to keep this like this. Usually you want to have some free body diagram that looks something like that. So you could easily take all your equations from it. So let's go ahead and decompose this force. So you have this force looking like that. The theta here was given 30 degrees. Now, what is going to be this and this component of the force? So if this is theta, this right here is going to be the sine. So sine of your theta is going to be your opposite over your hypotenuse. Where your hypotenuse in this case is going to be your force. And then your opposite is going to be this right here, which is going to be the y component of your force. So I'm just going to label it Fy. Now, this means that your Fy is simply going to be your total force times sine of theta. And similarly, your x is going to be your F times cosine of theta. So now, since we know that theta is 30, you could just substitute this for 30 and this for 30. Now, there might be a little useful tool that you might want to play around with, which is if you put 30, 45, and 60, and on one you're going to put cosine, and on the other, let's put sine up here, it's easier. Sine and cosine. There's this trick that says 1, 2, 3, 3, 2, 1. And then you'd square root everything. You also square root this one, but square root of 1 is 1. And this gives you all the value for sine. So say for example sine of 30 is going to be 1/2. So this is going to be times 1/2. And cosine of 30, you see it right here, is going to be root 3 over 2. So you don't have to put sine there. 1/2 cosine was root 3 over 2. So now you can come back here, erase this, and put in your x direction, you have an F times root 3 over 2. And then in your y, which way was it going? It was going this way, so you're going to have an additional one going this way at 1/2 F. Now, what do you do with this? Once you have your free body diagram, you're going to want to go ahead and write down all your equations that you can. So, and there's also a little, no, there's no tension here. Sorry, yes there is. There's a tension here from this one, from the rope, some tension. So, your total force, right, your sigma F, is going to equal the mass of whatever you're dealing with times your acceleration. Well, in this case, the mass is 5, and your acceleration is what you want to kind of leave there. So, again, leave your things in terms of variables. So this, remember, was 5. A is going to equal, so now it's all of these forces added together. So you're going to want to make two different things. So say here I want to make my x's, and here I want to make my y's. What do I mean by this? Is what are your forces in the y direction and what are your forces in the x direction? So in your y direction, you're going to have some acceleration on your y and some m. And this is going to equal what? Your positives are your normal force plus your 1/2 force minus that force that you got here, your mg. Now this is m1g. Now you have these two equations. Now, there's something that you might want to notice, is that hopefully this thing, if they tell you in the problem, it's not coming off. It's not accelerating in your y, it's not going up into space, and it's not going through this surface that it's at. So this is 0. And if this is 0, just this whole thing is going to be 0. Now once you have this, you could go ahead and add this. m1g equals your n plus your 1/2 f. Now this is one equation. There's going to be your next equation. So now you have two equations. Now you do the same thing for your next couple of things. So for m2 and m3 are very similar. They look just about the same. So m2, I'm just going to choose m2. I'm going to have some mg, m2g, and then upwards it's going to have some tension, right? And tension from this rope that is the same tension from that rope. And that's your thing. Now again, there's no x direction, so you don't have to worry about that. So you know that your m, your a, so this is going to be y, in this direction, is going to equal your t, because I want to choose that way to be positive, minus m2g. You could go ahead and choose down to be positive, whichever one works for you, it really doesn't matter. Now you have yet another equation. And you do the same thing for m3 and you're going to end up with a very similar equation. Just that instead of a 2 there's going to be a 3 there. Now the last thing is the free body diagram of the whole system. So what's going on in this whole system? The problem was to try to see what force, sorry I did not mention this before, what force do you have to pull at 30 degrees in order for this thing to not move? Now, this thing should have some force, then it should also have some, tension going this way, sorry, this is for M1. This whole thing should have 0 on the AX, so you could go back and put zeros everywhere there, and you could go ahead and solve for it. So your constraint equation, which is going to be part of your free body diagram equation, is going to be that the whole thing, all the forces added on the system, is going to equal 0, the whole thing.